Good morning, children. The next chapter that we are going to start today is Chapter 6, Heat and Energy. So, these are familiar terms for you, heat and energy. So, heat is also a form of energy. So, energy is the capacity to do work, right? So, we have 3 parts in this chapter, 3 units in this chapter. Let's do them one by one. The first topic is, now whenever we talk about heat and temperature, 2 terms that comes quite interrelated are heat and temperature. Okay, heat and temperature. So, they look like same, but they are different. Basically, according to physics, they are different quantities. In what way are they different? Heat is a form of energy. When I say heat, it's a form of energy that causes sensation of hotness or coldness. So, definition of heat energy goes like this. It is a form of energy that causes sensation of hotness or coldness. Whereas, when we say temperature, it's the measure of hotness or coldness. It tells you exactly how hot or how cold the body is. From heat, you may not know how hot or how cold the body is. It only tells how much energy has been transformed. Okay, whereas in case of temperature, it will tell you exactly how much hot or cold the body is. Okay, so these are 2 terms which there are 4 differences given in our book. You can go through them. The first difference, heat is a form of energy obtained due to random motion of molecules in a substance. Okay. Second, temperature is the quantity which tells the thermal state of a body or the degree of hotness or coldness. You can say any one is a quantity which tells, you can leave thermal state, you can just write degree of hotness or coldness. And even you can leave determines the direction and all that. So this is a form of energy, whereas this is a quantity which tells us the degree of hotness or coldness. Second unit, being energy, SI unit of heat is joule. Temperature, you all know, SI unit is Kelvin. There are other units like Celsius, Fahrenheit and all that, but SI unit is Kelvin, capital K. Then the third difference will be, the amount of heat contained in a body depends on mass, temperature and material of the body. Whereas temperature of a body depends on average kinetic energy of its molecules due to their random motion. If you remember, in 8th standard we had this chapter. First chapter we studied kinetic theory of matter, in which that theory said that all the molecules in a body are in a state of vibration. They are in a state of vibration. So, even though it is a solid, these molecules will be in a state of vibration. So, you know the energy possessed due to motion is kinetic energy. So, all the molecules are supposed to have kinetic energy. Now, if you take the average of all the kinetic energy of all the molecules, that is the measure of temperature. So, that is what is given here. Temperature of a body depends on average kinetic energy of its molecules due to their random motion. Then the fourth point, heat is measured by principle of calorimetry. There is no exact instrument used, but there is a principle used. In lab, we have to perform an experiment with the help of this principle to calculate the heat energy. Whereas temperature, we can directly measure using a instrument called thermometer. Next, we are going to start thermal expansion. The next page, there is a topic called thermal expansion. Now, as the name indicates, thermal means heat, expansion, you know that, okay? So, expansion due to heating a body is called thermal expansion. This you have studied last year itself, okay? Now, generally, what is the general behavior? Generally, what happens? Any matter expands on heating, expands on heating, and contracts on cooling. Okay, this is the normal behavior. Expands. Okay, generally, if you heat any substance, it expands on heating and contracts on cooling. Now, in this chapter, in this unit, we are going to see some unusual behavior of some substances. Okay, what is that unusual behavior? Instead of expanding on heating, some substances contracts on heating and expands on cooling. Is it clear? So generally, matter expands on heating, contracts on cooling, but there are some substances which show an unusual behavior, that is, they contract on heating and expand on cooling. Okay, now expand on cooling. Okay, this is given a name called anomalous expansion. Anomalous expansion of water. Anomalous means basically unusual. Now this is an unusual behavior of water, behavior of a substance shown in some special conditions. So we're going to study in detail about anomalous expansion. Now, look at the book. So, mark from here the expansion of a substance on cooling in a certain range of temperature is called anomalous expansion of that substance. So, this is the definition of anomalous expansion of a substance. Then, next important thing is examples. Very few materials show this anomalous expansion. Not everything shows. So, it's important to remember 3 examples are given in your book. I want you to remember all the 3. It is asked in tests sometimes. First example, water from 0 degree to 4 degree. Not in all temperature range, only from 0 to 4. So, it's important to mention the temperature also. Then second example, silver iodide from 80 degrees Celsius to 141 degrees Celsius. And third example, silica below minus 80 degree Celsius. These three are examples of anomalous expansion of a substance. Now, in this chapter, we are going to focus only on anomalous expansion of water. So, the next heading is anomalous expansion of water. Now, okay. Now, generally, imagine you have, you took a bottle, okay, filled it with water, okay, from the tap. So, maybe it is at, say, 28 degrees Celsius. Okay, the water was at 28 degrees Celsius. Now, you're going to keep it in a freezer. Okay, you put it in the freezer. So, what happens? It's going to start cooling. So, its temperature will fall down. From 28, it comes down 27, 26, 25, 24, 25, like that, 20. Then it goes on to 10. Then it goes on to, okay, keeps going down, right? Now, as its temperature is going down, as it's cooling, it will contract. Okay, it will contract. You may not see it visibly, but there will be a little bit of contraction. But once it reaches 4, okay, instead of contracting, it will start expanding. Instead of contracting, it will start expanding. Okay, so 4 to 0. Now till this, it was contracting, but only from 4 to 0, it started expanding. Okay, below 0, again below 0, it will start behaving normally, that is, contracts on heating, contracts on cooling. Okay, so this behavior of water between 4 degrees Celsius to 0 degrees Celsius is called anomalous expansion of water. Once again, I'll repeat. When water is cooled till 4 degrees Celsius, it will contract. Okay, contract on cooling. But once I cool it below 4, okay, when the temperature goes below 4, from 4 till 0, instead of contracting, it will expand. And this is called anomalous expansion of water. Then below 0, it will again start behaving in a normal manner. There are two important graphs related to this anomalous expansion of water that keeps coming very often. Okay, the first one is volume temperature graph, and the other one density temperature graph. Okay, one of these two usually comes in the exam. Okay, so you have to draw a graph and explain along with that. Okay, now we'll start with volume temperature graph. Okay, now what you're doing is you're taking water at 0. Okay, in the previous example I told you've been cooling from a higher temperature to lower temperature. So the reverse is also true actually. The reverse is also true. Okay, this was when you were cooling from 28 to 0 till 4 it contracted, between 4 and 0 it expanded. The reverse will also be true. If I'm heating, suppose I took water from the fridge. Okay, I took water from a fridge. Okay, the water was at 0 degrees Celsius. I poured it in a vessel. Okay, the water is initially at 0 degrees Celsius and then I started heating it. So what happens? Its temperature increases 10, 20, like that it keeps increasing. Now what will happen between 0 and 4? Okay, between 0 and 4 it should expand, but it will contract. Water will contract. Then after 4 you keep heating. After 4 it will undergo expansion till 20 or whatever temperature you're heating. After this it will undergo expansion. Okay, but only from 0 to 4 degrees Celsius, when you heat it, it was contracting. This is also possible. Not necessary only when you cool it. Even when you heat it between 0 and 4, instead of expanding, the water will contract. That is also a part of anomalous behavior. Now this is what we are going to plot in a graph. Okay. Now suppose you took water in a beaker. Initially it was at 0 degrees Celsius and you kept heating it. Okay. Now what will happen? Between 0 to 4 it will contract. Between 0 to 4 it will contract, and 4 to 10. Okay, we are doing till 0 to 10 degrees Celsius. It will start expanding. Okay, so how will the graph go for this now? Okay, so my graph, on x-axis I take temperature in degrees Celsius, and on y-axis I take volume in centimeter cubed. Though it is CGS, we are going to take it as centimeter cubed in this Okay, so now temperature I'm going to take from 0 to 10 degrees Celsius. Okay, 0, 2, 4, 6, 8 and 10. Okay, now this values you need not show everything. Okay, I'll just tell you what to show. Now what happens when you heat from 0 to 4, it contracts. Contracts means volume is decreasing. Volume is decreasing. So what happens to your graph is, so it was at some volume here. So till 4, it will contract. So your graph will go down like this. Till 4, your graph would go down like this. And after 4, if I'm heating after 4, it will start expanding. That means volume will start increasing. So your graph will go like this. I'll explain it again. So volume, we are seeing the relationship between volume and temperature of water when it is heated from 0 to 10 degrees Celsius. So 0 to 4, it will contract. 4 to 10 degrees Celsius, it will expand. So how am I going to show it in a graph? So 0 to 4, my graph will go down. In the sense, volume will decrease. From in 0 to 4, the volume is decreasing. Beyond 4 means 4 to 10, volume increases. So my graph is going like this. Now, in volume, one reading you have to remember, that is this reading. When the temperature is 4 degrees Celsius, volume will be 1, okay, volume of 1 gram of water in centimeter cubed. So volume, you will write it as number 1. So other readings you need not show, just write this as 1. 4 degrees Celsius and this will be 1. I hope you understood this. Now we go to the density temperature graph. Now density temperature will be opposite to it. So you all know that density is, formula for density, mass upon volume. So density and volume are oppositely related. Any body that has more volume will have less density, and a body which has less volume will have more density. They are oppositely related. So when I heat water from 0 to 10, same thing. When I talk about density, when I heat from 0 to 4 degrees Celsius, density will increase, and 4 to 10 degrees Celsius, density decreases. Density decreases. Is it clear? So here 0 to 4, it was contracting. 4 to 10, it was expanding. Here it is opposite. 0 to 4, density increases, and 4 to 10, density decreases. Now, how will I show it in a graph? Again, in x-axis, temperature, and y-axis, density. Unit, gram per centimeter cubed. Again, you are taking CGS unit. 0, 2, 4, 6, 8 and 10. Okay. Now, from 0 to 4, when I heat it from 0 to 4, its density will increase. So, your graph will go like this. You start from somewhere here. So, till 4, your graph will increase. Then after 4, your graph will start decreasing. So, this is the density temperature graph, and here when it is 4 degrees Celsius, the density will be 1 gram per centimeter cubed. So I want you to mention 1 here. You need not write the other numbers. There are many numbers given. You need not mention them. I hope this is clear. Once again, I'll repeat. You're heating from 0 to 10, and 0 to 4 density will increase. 4 to 10 density will decrease. So 0 to 4 density increases. It is maximum at 4, and after 4 the density will decrease. So this is the density temperature graph. Now, as I told you, one of these graphs usually comes in the exam. So Now have a look at the book. I'll just quickly mark it. Question number 12 is this question, like draw a volume temperature graph and explain it. Okay, the answer starts from here. The volume of water first decreases on heating it from 0 to 4 degrees Celsius and then increases on further heating it from 4 to 10 degrees Celsius. The volume of water is thus minimum at 4. For 1 gram of water, volume at 4 is 1 centimeter cubed. So till this will be your answer 12. And then the diagram, okay, the same, you need not show these values. It's enough if you just show this 1 alone, 1.000, or just write 1. Now coming to the density temperature graph. This is answer for question number 13. That question number 13 is about density temperature graph. To draw the graph and explain. So the explanation will go like this. So figure shows the variation in density with temperature in the range of 0 to 10. When water is heated from 0, the density of water first increases from 0 to 4 degrees Celsius and then decreases above 4 to 10 degrees Celsius. So till this is question number 13. Okay, leave off answer 14. So you can leave this part, that I'll do later. So till this you have to write for answer 13 followed by the graph. Again, you need not write these values, just write 1 at 4 degrees Celsius, that much is enough. I hope you have clearly understood these two graphs. They are very important. Thank you, children.